Hello, everyone. Thanks for tuning in. This is Umesh here, and today we are going to learn about Linux boot process and different types of init programs. We will also see how processes are created in Linux system, and finally, we'll look into managing processes and jobs, and also learn how to terminate them if necessary. So let's take a look at the boot process first. When the computer is turned on, it executes the code in the master bootloader to get the partition table information and finds the partition that your system is installed. It also loads the second stage bootloader, which presents you the graphical menu to select the operating system you want to boot from if you have multiple operating systems installed. And when you select the operating system you want to boot from, it will then load the program known as kernel, which is located inside the boot partition. And when the kernel is loaded, it initializes and configures the computer's memory and configures the hardware, which are attached to the system, including processors, input-output devices, and storage units. In the next step, kernel loads all the necessary drivers and initializes virtual devices such as LVM or software RAID if you have configured it. And kernel then mounts the partitions and executes the init program, which is a central system process and also known as init process. Init is short for initialization. Sysvinit, upstart, and systemd are three popular and widely used init programs. And now we're going to talk about these three programs in brief. Sysvinit was developed for Unix systemv, and that's how the name sysvinit came, for systemv initialization. Systemv was one of the first commercial version of Unix operating system developed by AT&T and first released in 1983. Later in the 80s, sysvinit was customized and adapted to Linux, and it worked well for many years, and in fact was being used by Red Hat until Red Hat Enterprise Linux 6. So it defines the system states as run levels and map all the processes and services with these run levels, which were defined in etc init tab file. And there are 6 different run levels, which are run level 0, which means halt and shut down the system. Run level 1 is a single user mode and does not configure network interfaces and do not start any daemons, nor allows any non-root logins. It is basically used as a recovery mode. Run level 2 is a multi-user mode, but does not have network interfaces configured and does not start daemon. 3 is a multi-user mode with networking, and it supports and have all the daemons running and start a system normally. 4 is not used, but it is user definable. 5 is X11, which means it's a graphical mode, same as run level 3 plus display manager if you have desktop environment installed. And 6 simply reboots the system. So you could do init space 0 to shut down, or init space 5 to go to the graphical mode if you have it installed, and do init space 6 to reboot the system. Or if you want to go into the recovery mode, do init space 1 and it will reboot the system and take you to the recovery mode. Sysvinit was created in the time when system had a static environment, but later with the modernization of computer system, it couldn't work properly for hot plug devices. And if your system was in running state and you attach a USB device, sysvinit couldn't recognize the USB device. Since this program starts all the services in a predefined sequence using shell script, the boot process was a lot longer and less efficient, especially if a script is broken or did not execute, and then another script had to wait until the earlier script timeout. And as a replacement for sysvinit, upstart was created and released in 2006. It addressed the problem of static environment and also solved some of the other issues of sysvinit. So it uses event-based service management, a synchronous service startup, and also automatically restarts the crash services. So instead of run levels, upstart uses system events to start and stop services. So whenever there is a change in a state of the system, like USB is attached or system is booting up or even service is started or stopped, it detects those events and makes necessary changes to the system. So Ubuntu used upstart until 15.04, and Red Hat started using upstart in Red Hat Enterprise Linux 6 just to overcome some of the problems created by sysvinit, but it was just a temporary move for Red Hat until the modern init program was developed, which would address all the modern compute and networking problems. That led to the development of modern init program systemd, and unlike its predecessors, it handles much more complex situations and has changed the way devices are mounted, how services are created, how the swap area is allocated, which can now exist within your root file system, and defines targets for run levels like situation. Some of the major features provided by systemd are: it does not work in sequential mode like sysvinit. Services are started parallelly. It automatically resolves dependencies. It creates log events and also create snapshot of the system, which I talked in my very first video on this channel. And it supports hot plug devices as well as large data stores, and also addresses concern for cloud architecture. So Ubuntu started using systemd since 15.04, and Red Hat started since Red Hat Enterprise Linux 7. And today, all major Linux distributions, including Kali, Red Hat, Ubuntu, CentOS, use systemd, which is controlled by systemctl command. And systemd has a different units to handle different services. So if you want to see the status of logging daemon, then you can simply type sudo systemctl status systemd -journal d build service, and you can see the service is active and running. And if you have other services, like for example SSH, you could type systemctl status SSH service. And if you want to start the service or stop the service, stop the service and start to start the service. And if you want to disable SSH during the startup, you can simply type disable SSH service, and to enable, just simply type sudo systemctl enable SSH service. So that's how you can control the services daemon in systemd environment. You can also do service systemd journal d status. So this is also the same thing. And you can use systemctl command to define your default run level as well, like we did in etc init tab file for sysvinit program. In systemd environment, you can type sudo systemctl get default will give you the default run level. So right now it's a graphical.target. That means whenever you boot up your system, graphical environment will be started up by default. And if you want to run in text-based environment, then you can do sudo systemctl set default. And for text-based, you type multi-user.target. So when you do that, now next time I reboot the system, it will start in text-based user mode, like init 3 in older system. And if you want to change back to the graphical mode, systemctl set default graphical.target. Default target is removed and created another symlink and defined graphical target as my default target. It's the same like you do id :3 : init default in your old etc init tab file. Or if you're still using sysvinit program, then you still go to init tab file and change it. And if you want to make it graphical, then you just change this to the file and save and reboot your system. Even though systemd does not use init tab file, you can still do init 0 to shut down your system, init 1 to run in single user mode, 3 multi-user mode, 5 graphical mode, and 6 to reboot. You can still use this command. I'm using this in my Ubuntu 20.04, and hopefully your modern system which uses systemd can also use that command. So systemd starts all of the background processes by looking in the appropriate RC directory for the run level. So RC directories are numbered to correspond to the run level they represent. For instance, if you go to etc rc 5.d directory and do long listing, these are all the programs that will run when your system run in run level 5. Now let's look into the process of creating other processes. So every program that you run comes into execution through process, and process is a special program designed to run specific tasks. Every process is initiated by a parent process except one central system process, which is initiated by kernel during the boot process and known as init process. And every process has a unique process ID, also known as PID, and a parent process ID, or PPID in short. So now we know that kernel starts the init process, and hence it takes the PID 0 and assigns PID 1 to the init process. We can see it by using ps-f1 command. So you can see here the user ID root. So root initiated process init, which has a PID of 1, and parent process ID of 0, which is for the kernel. So if you do long listing of sbin init program, you know that it is systemd because we are running in systemd environment. You can also look the manual page for systemd, which is the init program, and it's a service manager for the system. If you do init, it will also give you the same page. So systemd is basically init program for this Ubuntu Linux. Processes are created through different system calls, but most popular are fork and exec. Fork creates a new process by duplicating the calling process, and the new process known as child process has its own unique process ID. The parent process ID or PPID would be the PID of the process which called for the child process, and child process does not inherit parent process memory locks or any input-output operations. And exit creates a new process by replacing the current process with the new one. So it does not create a new one, but just replace itself and create a new process. So let's look at fork and exit concept. So when you type ls, bash creates another cell by using fork. So fork simply means it just duplicates process, and the new cell creates a child process ls by calling exec and executes the ls command within the newly created bash cell. And once the process is completed, child process will disappear, and the parent process, which is the bash in this case, returns back with the status code of 0. And if in case there is an error, it will return the code of 1 to the parent process. Let's open another terminal and let's look at fork and exec concept with an example. So let's do ps-f here. It gives me all the process running on this terminal bash cell, and ps-f here. So this bash cell running on this terminal has process ID of 3292 and parent process ID of 3281. Similarly, on this terminal, parent process ID is same as this one and different process ID for this bash terminal. Now, if I do sleep 400 command on the second terminal, which will take this terminal or bash cell into sleep mode for 400 seconds. So now I can go back onto the first terminal and do ps-ef, which will display all the programs running on this system, but I'm only interested on sleep command running on second terminal. So this sleep 400 command has PPID 5901, which is the PID for this bash cell. Since this bash cell ran this sleep command by forking it and then executing it by using exec command. So the parent process ID for this sleep command is the process ID of the cell that it executes it. So it's a concept of fork. So actually the second terminal forked itself and created another terminal for sleep 400, and that terminal or that process as a child process exec and then ran this command. That is why PID of this bash terminal is PPID for this sleep command. Now let's suspend this job and run exec sleep, let's say 200. So in this example, what happened is the second terminal bash actually replaced itself and created a new process for sleep. So in previous example, without the exec, bash forked itself, duplicated itself, created another bash cell, and then created a child process for sleep command. But in this case, bash simply replaced itself and created a process for sleep, which we can verify by going into the terminal one again and run ps-ef grep command one more time. So in this case, sleep 200, which is the command that we ran with exec, has process ID of 5909 and parent process ID of 3281. So 5909 is the same PID for the bash. So it simply means this command, sleep 200, is the same process as this bash because the process ID is similar. Before it was just a parent process ID and it had different process ID, but in this case, bash has the same process ID as the sleep 200 command. And what happens is after this 200 second is passed, this bash terminal will disappear itself because that's how the exec works. So it creates another process by replacing itself and disappear when the function is completed. In case of fork and exec, fork duplicates itself, create a child process, and the child process called for execs. So whenever the process is completed, it go back to the parent process, which is the bash terminal itself. So let's wait for 200 seconds and you will see that second terminal will disappear itself when the process is completed. So I'm going to fast forward to 200 seconds. And it disappeared because exec just replaced itself, and when the process is finished, the cell disappeared. So actually same thing happens when you do, let's say, exec ls-l. So when I enter, so what happens is the terminal will replace itself, create another process for ls command, and when it lists, the cell disappears. but if it's a fork and exec, you can just type ls command. So in this case, this bash terminal created another terminal, duplicate itself, and then the child process, which is the new terminal, run exec command and then display the directories and files within that directory and simply disappears. So that's why you see the same cell again and again, because it creates another one, duplicates itself, run the command, and comes back to the parent process. So that's how fork and exec actually execute process in cell terminal. Make it bigger. And if you run exec by itself without any command, it will simply make the redirections apply to the current shell. So you know that if you do cat test, and so what happens is you type anything on the terminal, it will actually redirect to the file. So if you do cat test, so whatever you type was written on this test file. So this is called a redirection. So you're redirecting the output to the file. So when you run exec by itself without any command, it will simply make all the redirection apply to the current shell. And if you run exec, let's say file, so what happens is the redirection applies to the entire cell, and any output produced by the cell is written to the file instead of displaying on the terminal. Now let me run the command date. See, when you type date, it didn't display anything, because when we did exec redirect to the file, so whatever the output of the entire cell is redirecting to the file. To ls, no output. It's because everything is redirecting to the file. So to get out of the redirection, simply type exit, terminal of the cell, open the new cell, and then ls, there should be a file. And if I do cat file, so the date output and the ls output was written on this file. So this is how the exec will redirect any output from the terminal to the file. Now we know how processes are created. Now let's take a look into how to kill them. So ps-f simply displays all the processes running on this terminal. ps-ef displays all the processes running on this system, and it displays PID, PPID, the time, date, and which terminal it's running. Now to kill the process, we have a command kill. If you do kill-l, it will give you a list of the kill signal. So most used signal is 1, 2, 15. 15 is simply when you type kill and process ID, it will send a 15 signal, which is sig term, signal for termination. 2 sigint, signal for interruption, and 9 is another signal to kill the process. So let's take a look. Let's open another terminal one more time. Let's open Genome software, for example. So it simply opened this application manager, package manager. I'm going to keep it open on the side. And if I do ps-ef grep Genome software. So this is the PID and this is the PPID for that application. And if I want to kill that process, I can send a terminate signal, kill. If you do kill or kill-15, it's the same thing. It will send sig term, so signal for termination. So this is a voluntary termination. So this signal will be catched by process, and process will save any unsaved data from buffer to the disk space and try to terminate itself. Kill 2769, send the termination signal. Process was closed, and you'll see that output on the terminal. So the terminal is free and the process is closed. And run again. And for some reason, if it did not close by sig term, then you can force by kill-9. Let's take a look at the process ID first. Kill-9 6919. So the process is open, and so the process is closed. In this case, it was involuntary termination. So actually, kernel took all the resources out of the process and killed the process without its knowledge. Process didn't know that it was getting killed. So in this case, the data was not saved from buffer to the disk space. So if you do kill-9 and the process ID, you will lose any data that was unsaved to the file system. So it's safe to send a kill signal using kill command or kill-15 and process ID. That way process will take some time, try to terminate itself voluntarily. So that's how you can terminate any job. Kill space process ID, or kill space -9 and process ID if simply kill didn't work. Now let's take a look into the running jobs into background or foreground. So job is just a program which you can run interactively without detaching. Now we'll see how we can run, suspend, or kill jobs. And I have another terminal open. So I can simply type Firefox, will open the Firefox browser. So when I run Firefox command on this terminal, see the terminal is occupied by the process. So if you just type Control-C here, what happens is this terminal actually sent signal for termination to the Firefox, and Firefox closed itself. So Control-C just simply kill the process, and your terminal is free for other jobs. You can also send the running process in the background. For example, Firefox, simply open the browser. If I press Control-G, so now this job is stopped. If I type jobs now, Firefox job is stopped. Yes, EF grep Firefox. So this is the PID for the Firefox 7856. Now if I go on the Firefox, I cannot type anything because the job is suspended. Resources is taken. So now if I go here and do BG, it will run the Firefox in the background. See, now I can type it. Now the resources are given back to the process. And if I do jobs now, the Firefox is running. And now if I want to kill this process, I can type kill and then percentage job ID, in this case 1. And the Firefox is closed again. And if I do jobs, no more jobs. The Firefox is terminated because I sent the kill signal, kill sig term. You can also run the job directly into the background by running command with the ampersand at the end. So Firefox ampersand Firefox is running in the background and the terminal is free. Jobs, so one Firefox is running. And if I want to bring this job to the foreground, then FG percentage job ID, or if you have only one job, then just FG. And now Firefox is on the foreground and your terminal is occupied. And Control-G, suspended, cannot browse, and then come back again, BG percentage job ID, or just BG if I have only one job stop. So now the Firefox is back. And if you have multiple, then let's just sleep 300 ampersand sleep 400 ampersand, or just type sleep 50 Control-Z, send it to suspended mode, jobs. So Firefox is running in the background, sleep is running in the background, sleep 400 is running in the background, but sleep 50 is stopped. So you can type BG percentage full jobs. Now that is also running. And if you want to kill sleep 300, kill percentage 2 jobs, 300 is terminated, and other 3 jobs are running. And if you want to bring sleep 400 in the foreground, FG is 3, and now sleep 400 is on the foreground. Control-G again to interrupt jobs, kill percentage 3. You can actually do kill 1, 3 together. No such job because 3 was already terminated, and 1 we just terminated. So this is how you can run any jobs in the foreground, background, start job in the background, start in the foreground, and then suspend it, and then run in the background, all kind of stuff. So I hope you guys find this video helpful. We talked about how the boot process is taking place in the Linux system, what are the different type of init program, how processes are created, how we can manage processes, and finally how we can look into the jobs and run into the background and foreground. So I hope I was able to give some information to you guys, and hopefully you find this video helpful. If you have any questions or comment, please leave them in the comment box. Thank you for being with me, and thanks for watching. I'll see you in the next video.